Alright guys, we're back. And this is honestly probably going to be my favorite video because this is the behind the scenes stuff that makes all the magic happen, and it applies in so many other areas when we create our scoring system. This is stuff that gets me excited. We're going to get a little bit nuts, but it's going to be really cool in the end. I hope that you stick with me here. So, just to go over this briefly, we created 3 different ways to do cutoffs: standard deviations, arbitrary, which we enter, and max or min values of a data set. And what I'm going to do right now, just for consistency, is things that we need to type in, I'm going to make yellow. And I'm going to do that throughout this, because there are going to be more things that we might have to type in. So, first we need to figure out what's going to determine which of these values to use for our scoring system. We can't use all 3 at once. And you may actually only have one, and this might not be relevant to you. But I'm going to create a list, maybe down here. I'm going to say, we're going to call this the cutoff list. And I'm going to do std, sounds bad, arb, and for max min. Now what I'm going to do is, I'm not sure where this is going to go yet, but let's just do it here for now. This is going to be where we pick which of these we want to use for each metric, and ideally it should be the same for all of them, but why not give us this flexibility just in case? What I'm going to do now is I'm going to go to insert, or I'm going to go to data validation, pick a list, and I want to pick the list from these 3 things. There we go. Click OK. And let me just color this yellow, and I'll pick one for now. std. Save. Let's say cutoff picker. Doesn't really matter. Okay. Now we have an area to pick which one of these things that we want to use. But before we get into this stuff, what we need to do is we need to have score values. In other words, what is the maximum and minimum score we want? Say max score, min score, and eventually we're going to need a difference, or difference between the scores. I'll say score difference. For me, let's say I want my scale to be from 0 to 100. I would type in 100 here, 0 here, and the score difference is actually going to be this -1, and I'll explain why in a little bit later. So equals this minus this minus 1. Oop. Let's do -1. So here we're typing in these things also. And actually, let me remove the colors from this. Sorry, it's just throwing me off. And I gotta name this better. I'm gonna say max min, or I'll just call them by their names. good cutoff, bad cutoff. And why not give these, I'll say arb good cutoff, arb bad cutoff. And you know what I'm going to do now too? I'm just going to highlight these things. All the good things, I guess. Just give them a little tint of green, and maybe highlight all the bad things. Give them a little tint of red, just so we can tell. It's kind of quick, easy for us to identify things. Okay. So far so good. And what we're going to have to do here is we're going to have to create a little bit of space because we have all these categories. Normally, I just do it with one category, but because now we have a lot of things going on, we have 3 different groups. Let's add two spaces here, and I'm going to remove the colors, just to be safe for now, and hopefully this will get the point across. Now we need to enter where our scores are going to go, and let's move them down here because we need room for some other stuff. One field is going to be value, and one is going to be score. Now, our best score is going to be whatever we set it to. So I can say equals this. That's our max score. Click enter. But now, what is the next value going to be? Well, it's going to be 1 minus our max score. But at a certain point, we're going to get to 0 and we're not going to want to go any further. And you could easily just type in all the numbers, or you could, I want to make this smart so that I can just drag it down and not worry about it. So I'm going to say equals if whatever this is, which is our max score that we set, minus 1 equals, if that equals 0 or our lowest score, comma, then I want our lowest score to show up. But if the score above it equals our lowest score, comma, I want it to be blank. And if nothing else is true, comma, I want this minus 1. And all I'm going to do right now is I'm going to lock in our lowest score value because it doesn't move. I'm locking the D14s. Everything else is fine. And let's close some parentheses. And maybe I'll say if error, if there's an error, comma, let's make it blank. Doesn't really matter. But so all we've done is we're essentially subtracting 1 from this number unless it equals 0. And if it equals 0, we're going to stop subtracting stuff. So if I drag this down as far, it doesn't matter how far I go, I can just keep on going. It'll go from 100 down to 0 and no further, because I said if this is 0, then make it blank. Okay. So now we have values going from 0 to 100. And if we change this, let's say we want the scores to go from 30 to 100. If I scroll down, they should only go to 30. Okay, let's bring this back. And the same thing, if I change this value, maybe I want my scores to go from 20 to 50. 50, 20. Now my max score will be 50, and my minimum score will be 20. I hope that makes sense so far. Let's go back to 100 and 0. Now, the fun part. Values. Okay, before we get there, we got to get minimum and maximum values and differences for whatever we select. So what I'm going to do here is I'm going to say max, min, diff, and I'm actually going to move all this stuff down down a little bit. Let's just move it down a little bit. That's fine. I should have done that. So diff, and then let's say score diff. These are the things that we're going to need. And the way that I'm going to do this is I'm going to say these values are going to be what determine our value range. So I'm going to say equals if this, whatever's in this box, equals the first thing in our cutoff list, which is what we set up, and we'll lock that one in, comma, then we want this value as the maximum value in our value list, comma, but if this, whatever's in that box, equals the second thing in our cutoff list, and let's lock that in. Well, that's arbitrary. We want the arbitrary good value, comma, if whatever's in this box equals the third thing on our cutoff list, and lock that in. Then we want the min-max good cutoff value. And if none of those things are true, let's just say blank. And I'm just going to close all the parentheses like that. And I'll always, as I always do, I'll do my if error. If there's an error with anything going on here, comma, let's make it blank. Click enter. So now what we have for a maximum value is 34.17. That's our standard deviation good cutoff value. And if I change this to arb, now our max value is going to be our arbitrary good cutoff value. So let's go back to standard deviation for a second. And there's a reason why I'm not locking these, all the other cells. We're going to have to do a couple manipulations to do all these things. But then when we copy, because what you're going to have to do is you're going to have to create these scores for every single metric that you want. And it'll be much easier to copy and paste across if we do it this way. So I'll copy this and paste it down. And we're going to have to make some changes. So it's kind of a mess right now. So instead of D16, which is what it was before, if D18, if D8, if D8, wait, no, D16, sorry, if whatever's in this box equals the first thing in our cutoff list, that stays the same, then we want D8, that's right. And we just have to change this back to D16. If whatever's in our box equals the second thing, then we want D10, which is right there. And if whatever's in our box, which is D16, equals the third thing on our list, we want D12, which is the bad cutoff value for min-max. And everything else stays the same. And if I click enter, now we have the minimum value for the standard deviation cutoff. And if I change this to arbitrary, we're getting the min and max arbitrary values. And if we do the min and max values, we get, or cutoffs, we get those values. So let's go back to standard deviation. Now difference. Now what we need to do is we need to calculate the difference between these two numbers, our good cutoff and bad cutoff value. And we do that by just doing this minus this. So the difference between the best, or the good cutoff, and the bad cutoff is 12.6 inches in this case. And now we need to get a difference per score, or per change in score. So what we do now is we go equals this, the difference between those two values, divided by however many markers there are in our score. And I'm going to click enter. And that's 0.275 something. But if I make this score range less, let's say I make it 50 to 100, this number will go up because there are less points in the scale. But let's go back to 0. And this can be any number, these can be any numbers you want. So now comes the interesting part. Or this is kind of the whoa moment. So for the value that equals 100 or anything greater than this value, we're going to pick the max value that we selected here, or that we calculated here based on what we select. Click OK. Now everything beneath this is going to be a subtraction of this score difference from the maximum value, and eventually we'll get to our minimum value, our minimum cutoff value. So I'm going to say equals this minus this, and click enter. Oh, maybe I'll say, yeah, I'm going to say equals if this equals blank. If the cell next to it equals blank, let's make it blank. If not, then we're going to do that minus the score difference. I'll do if error blank again with this. If there's an error with that, comma blank. So all I did here is I said, if this is blank, let's make this blank, because I just don't want a bunch of numbers. I want to be able to drag it and just do whatever. But if not, we're just subtracting the score difference from the value above it. So I'm going to drag this down to the bottom, and I should be able to drag it down even further. Did I do that wrong? Oh, I know what I did. My apologies, guys. Before you drag it down, we need to lock in E21. Or you know what, maybe we just lock in row 21, so when we copy and paste it, it'll be better. So I'm locking in row 21 by putting a $sign before it, and I'll click enter. Now, if I drag this down, I hope, we have scores going from 0 to 100. And what this means is that if you jumped this high, you would get a score of 56. If you jumped this high, you'd get a score of 76. If you jumped this high, you'd get a 100. And if we change this to arb, now if you jump 30 inches, you get 100, and if we go down to the bottom, we should get our lowest score pretty much at the bottom. If you jump lower than 18 inches, you get a 0, and that's our minimum cutoff score. So I hope that makes sense. Oh, you know what? Oh no, I did do it. Okay. So this is pretty cool. We can kind of change what we want to look at, min-max values, and again, we're going to have a jump height that's associated with each of these scores. Now, before I go any further, what we can do is we can go into our data. I'm going to add a column, and we're going to create a score for every single metric. Now, there's one kind of catch-all way to do this, but depending on which method you pick, you might not have to do it. If you do the maximum minimum method, and most likely the standard deviation method, depending on if you're doing 2 standard deviations or more, you won't have to do this. But especially when you're setting arbitrary cutoff values, you'll have to do this. And maybe I'll start off the simple way without doing it, and you'll see what I mean. So in general, we're going to use something called index match. And in this cell right here, in our table, I'm going to do equals index, or maybe I'll name this first. I'm going to say CMJ best score. Or maybe I type in score CMJ best just to keep it consistent. Oh, equals index. So what do I want to return in this? I want the score to show up here. So I'm going to go to my score panel, and I'm going to select all these scores. And I'm going to lock them in. Comma. And I'm going to match it to, let's go back to our data. You got to go back and forth. Where is that CMJ best value? Right here. This, whatever this person's CMJ best value is, comma, to, what am I matching it to? I'm going to match it to the scores in here, or the values in here. And again, I'm going to lock this in for the D, for the 25, before the D, before the 125, comma, and I'm looking for something less, greater than, so I'll do -1. And let's close off the parentheses, and I'll click enter. Now let's just sort this largest to smallest. But this is so I want to show you something bad. All right, so if I go to my score panel, let's change this method because we're using max min and everything will work. But if I go to arbitrary, let's say, and I go back to my data, I'm going to get a bunch of NAs up until a number. I'm gonna do some hiding first. Sorry, I'm gonna do some hiding so that we can see what's going on. So CMJ best is here. Up until 30 inches, everything works okay, but everything above that gets an NA because it doesn't know what to do. And in certain cases, anything below a certain value, you might not know what to do either. In this case, I think it's fine. But so what we're going to do is we're going to work around this in case you are using arbitrary cutoffs, and we're going to be able to do some if formulae to make it work. So before all this index happens, we're going to say if whatever this is greater than, let's go to our score panel, if it's greater than this max value, which is based on the one that we set and the thing that we choose here, I'm going to lock that in. If it's greater than that, we want to give someone the maximum score that we set. So I click on that, score panel D13. comma. Then we're going to say if, we're going to do the same thing that we just did, but maybe I can copy all of this stuff and we can change it. Or you know what, I'll go back and I'll just do it. So our second if statement, let's go in our data again. Now if this is less than, going back to our score panel, I know it's a lot of back and forth, but we only have to set it up pretty much once. Well, we have to set it up a bunch of times, but we can change things. If the CMJ best is less than whatever the minimum value is here, and let's lock that in, comma, then we want to give them the minimum score that we set. And let's lock that in. And if those things aren't true, comma, then we'll do this whole index thing that we decided on. And I'll close all those parentheses and I'll click enter. Now, people even above 30, they'll all get a 100 if they're above 30, because that's the arbitrary cutoff value that we set. And everyone that gets below whatever the arbitrary low value is will get a 0. So no one's below that value, but let's set it to be below that value. I'm going to set this for our arbitrary cutoff on the CMJ best. I am going to set the low value to be 25. Click enter. So now what you'll notice, at least in our value range, and hopefully this is hitting home now, that it's a lot narrower of a range. So we're going from 30 to 25. So someone that gets a 26 is going to get a 40. And as we go down, 25 will get a 1. But if we go to our data now, there are going to be a lot of people with 0 values up until we get to 25. And then they start increasing, and then they'll stop at 30, and everyone above 30 will get a 100. I hope that makes sense. If it doesn't, let me know. I'm going to go and reset these values to, I actually don't even remember what this was. I think it was 16. But now we have a dynamic thing that will adjust to pretty much anything that we do to set our scores up. And we just calculated scores from 0 to 100 on a metric. And when we do this, for each metric, we can do compiled scores. So maybe we go through this with the rest of the CMJ stuff with this. So let's create 2 columns here, and we already have a couple columns here. And let me just remove all this yellow. We can copy this stuff exactly. We can actually copy all this stuff exactly. We can copy all this stuff exactly. And we're just going to have to change a couple things. But copy all this stuff. Paste it here. Let's paste it here. Everything's working the same way. See, notice these min and max values are coming from this data set now. 37 and 21, because we're on arbitrary. We could even change this one to be standard deviation, and it'll go off the 2 standard deviation values here, 34.49, 21.23. But we want all these to be arbitrary, all these categories. And all these values, let's just make sure. Yep, everything looks like it's pointing to the right stuff. But the difficulty is going to be with our formulae, where right now in our data set, we're getting a CMJ best, and it's based on criteria for one cohort. But what you really want to do right now is, based on the way that I have it, is you want their score to be different depending on which cohort they're in. So things get a little bit more complex from a formula standpoint here. If we only had 1 and we had everyone on the same score experience, and that would be one thing, but we don't, because we have 2 groups. So what we're going to do to start is we're going to say if, and I'm just going to click Alt Enter to separate things. I encourage people to do this because it makes things easier to read. If this group that the person's in is equal to, let's go to the score panel. It's equal to this group right here, which is the U18s, comma, then we can do what we said that we're going to do because we're looking at the data for the U18s. But if they're in the U20s, we're going to have to do something else. So, comma, if, and let's go back to our data, if the group is equal to, go back to our score panel, this group, let's lock that in, comma, we can copy everything that we've already done here. We've already done almost all the work. Hold down Alt and click Enter. I'm going to drag this down so you can see the whole thing. I'm going to paste it again. But I'm just going to change a couple things. Because instead of score panel E18, which is here, we need this one, which is H18. And similarly, instead of D13, which is here, we're going to be looking at G13. So instead of D13, we're looking at G13 because that's the one in the U20s group. And instead of E19, we're going to be going to H. So pretty much replace all the E's with H's and all the D's with G's. So replacing the D with the G, replacing the E again with the H, and the E with the H, and the D with the G, and the D with the G. It's a pretty good song. I'll take that out. I'll say if none of those things are true, or let's just close all the parentheses and see what happens. Click Enter. So now when I do that, let's scroll this up. You'll be able to take a screenshot of this. Maybe I'll supply this formula too. I should really supply all of these. So now what we're looking at is some person, they got a kind of, let's hide everything. Let's hide everything except for that so that we can see what we're talking about here. So one person got a jump of 31.7. They're in the U18 group. They got a 100 score. Let's check. The U18 group, anything over 30 is a 100 score. That makes sense. Let's go back. Now this person in the U20 group got a 68 score with the same jump height. So let's go to the score panel. In the U20 group, well, the range is different. 31.7, where is that? Let's find it in here. 31.7 is about here, somewhere between here. So they got a 67 or a 68. And when we go here, they got a 68. So all this is showing is what we did is working. And we have an opportunity, now our flexibility is tremendous. We have different scores for different groups. And when we copy and paste this across different metrics, we're going to have them for different metrics too. Right now, we've only dealt with the counter movement jumps, the best score. So now, probably the first thing that I would do is I would take all this stuff that we've done here. And what we're going to do is we'll insert 2 columns between everything just to have it available. I'm going to do it. You might not want to do it. All of our metrics. Again, I'm going to add 2 columns in between each just so everything fits nicely. And you could probably honestly skip over this if it's not relevant to you. But all I'm going to do, again, is just add 2 columns in between each metric so that I have a place to copy and paste everything. And then the hard part's going to come where you need to adjust the formula a little bit to accommodate for the metric that you're looking at. But once you do that, you should have essentially an individualized score for every single metric you have, which then you can use to compile categorical scores and even overall scores on any scale that you want, on any metric that you want, using any means that you want. And hopefully you can see how this system applies to more than just fitness testing. It could apply to load monitoring. It could apply to really just any sort of grading that you do and various other contexts. So again, I'm just kind of, as I'm talking here, I'm increasing the amount of columns here. We don't really deal with this much. We should really just set this once and forget it for the most part. And the way that it looks is not great right now, but we can always make alterations for that. And from a scoring perspective, we're going to have to do some different things, slightly different things, I should say, for the metrics where lower is better and metrics where, I guess if we're looking at asymmetries, where I guess lower is better if we're using absolute numbers in our context. But we'll get to those hurdles in the next video. In this one, all we're going to do, or all I'm going to do, is copy and paste what we've done to everything else. So all I've done right now is I've created 2 columns in between each metric to replicate what we did here and give a little bit of space. But what we need to do before we start copying and pasting stuff is, what I didn't do, because I was going through this rather quickly, is we have D14 locked in these scores. D14 is locked here too. So the first thing that I'm going to do is we're going to unlock D14 before we copy and paste things around. I'm going to select all these cells, and I've already actually done this in my window, I think. I'm going to go find, replace D14 with $signs with D14 without them. Perfect. 303 replacement sounds about right for that range. And now, in this one, we're going to change D14 with $signs to G14 without them. Because when we were looking at D14 here, we're looking at this cell, the min score. Now we're looking at this min score, which is G14, and we'll replace the other ones with J. And obviously you don't need all 3 of these, but I've done it this way, so I'm going to do all of them. So I'm going to replace this. Instead of D14, let's go to G14, and let's replace that. Perfect. Now the same thing here. Instead of D14, we're going to look at J14. Let's try that. So D14, let's do J14. Should make about 300 some odd replacements. Okay, perfect. And the reason why the number of replacements are changing is because I dragged these formulae down here, even though nothing's showing up. So that's why the number of replacements were different, but all the ones in here are good. So now that we have done this, and if we check one, yep, J14 is not locked, G14 is not locked, D14 is not locked. Now we can copy and paste all this stuff from up here all the way down. Let's copy it. And we can paste it here, everywhere. Paste it everywhere. And we're always going to choose the first cell beneath the bad cutoff. And paste, and paste. I'm holding down Control and V to paste. Paste. And the other way to do it, I think like we've gone over before, is if you don't want to go one by one, is I can go and click this cell, click that cell, as long as I know which cells are the right ones to paste into, click that one. I'm holding down Control as I do this so that multiple cells are selected. I don't know how these are already here, but it doesn't really matter to me. I'm going to repaste them. Why these are already here? Hold down Control. Yours will be empty. I'm just holding down Control, holding down Control, holding down Control and clicking on the first cell in each of these areas. And then I'm going to hold down Control and V, paste. Now all my formulae should be updated for all these components. And let's test one to see if it works. one where higher is better, not lower is better, so we haven't worked on those. So if I go to the TBDL1RM, let's say, we're set at arb, which means that we're using the arbitrary good cutoff, which is 400, and the arbitrary low or bad cutoff, which is 175. That's where we see the max and the min here. The difference and the score difference is calculated from that with the max and the min score that we set. And we'll notice the best score, or 100, is anything over 400. And the lowest score is anything under 175, which is what we set it to be. Now what should happen is, if I change this to be, let's say MM, the maximum and the min and the best score and the lowest score too should reset to be the MM low cutoff and the MM good cutoff. And furthermore, if I change the scale, let's say for whatever reason I want the trap bar deadlift score range to be anywhere between 30 and 100, change this to 30. Again, my score difference will change, and if I scroll down, my trap bar deadlift low score will occur at 30 instead of 0. Now let's set this back to 0. Maybe let's set this back to arb so that we're consistent. Oh, I guess I had data validation in each of these things, but not that it really matters. It won't change anything. It won't change anything. All right, so we're good. Got all of our scores. Everything is completely customizable. The only thing left that we have to do, besides changing the lower is better stuff, is in our database now. Now, this is where the fun begins, and this is where I'm not going to do all of these metrics because it's too much. It's too much for me. Maybe we'll do a couple. We'll do one from each category, and then you can do your own. But essentially what we're going to have to do, all right, remember we hit all this stuff. I'm not going to do the CMJ average. I'm going to create another column. Let's move this one over. And what's another category that we have here? All right, I'll do the Wingate relative peak power. Let's copy that header and let's paste it in here. And let's say, oh, first we say score. So this is a score for the Wingate relative peak power. We've already done a lot of our legwork here in this formula. You can copy it, paste it here. It's as a percentage. Let's change this number to be a number. Maybe we actually remove the decimals from each of these. We can do that. And now we need to manipulate all this stuff because right now we're looking at D3 and G3 and looking at a lot of different things. So pretty much if I go to my score panel, I can figure out what to replace by saying instead of D's, we're going AKs. Let's look at it. Instead of D's, going AKs, and instead of G's, we're going to whatever the next one is over. So instead of D's, we're going to AKs. Instead of G's, we're going to ANs. And the rest should kind of take care of itself more or less. So I go to my data. Instead of D, and we can actually do this. If I highlight this whole thing, I go find replace. If I replace the D with AK, replace all, you get a lot. I replace the G with AN, we'll get a lot more. Now there are two things left to do. It's what's going on in here, the score panels. We have E19 and we have H. So we have E and H and we need to replace those. So if I go back to my score panel, it's probably a better way to do this, but let's look at our, so we're replacing E's, which is the letter after D, and H, which is the letter after G, with whatever come after the letters that we have in here. So AK, we're replacing E's with AL, and we're replacing H's with M and O with AO. So let's go E, find replace, E with AK. Oops, that's a problem. I gotta undo that because that's supposed to do with AL. E with AL. And H with AO. And replace. And now if we do that, we should have a score. And I'll just bring that down and bring it up for everybody. So now the last thing that we have to do is we have to replace this, which is the CMJ best, with the Wingate relative peak power field. So I know it's a lot, but we can replace CMJ best. I'll close that down with the Wingate relative peak power. Find, place. If I click replace all, now we have a score for Wingate relative peak power for everybody. And let's just sort this largest to smallest, and let's just look at it really quickly before we move on, before I end this video. So highlight all that, hide it. Let's hide the. So we got a score of 15. They get 100. Score of 15, or maybe I sort this largest to smallest. So one person has a 15.3. They're in the U18 group. They got a score of 100. Another person has a 15.3. They have an 88. They're in the U20 group. Let's check that. If I go here, where's that Wingate relative power? The U18 group here, anything greater than 15 will get a 100. And remember, we're looking at the score of 15.3. In the U20 group here, let's try to find where 15.3 lies. It's somewhere about here. Person got an 88. Perfect. With a score of, with a value of 15.3. That's perfect. So everything's working fine, and this has been a long video. This is all I'm going to do in this one. In the next one, we'll go through the lower is better stuff, and we'll also go through a couple more of these scores, get you used to the find replacing, and hopefully it's helpful. In the end, it's going to be a really robust solution that I don't think anyone else really has. So let me know your thoughts. I apologize that it's confusing. Don't worry, in the end, you'll get a file that you can just use if you want. Thanks for watching.